Hey there. So you're a Python developer. You've got the basics down, but you're kind of wondering, what's next? How do I really level up my skills? Well, you are in exactly the right place. Today, we're laying out the roadmap that takes you from an intermediate coder to a pro Python engineer. Let's get into it. Does this sound familiar? Your code works. Your scripts do what they're supposed to do. But you've got this nagging feeling that you've just kind of hit a plateau. You look at code from senior engineers or in big open source projects, and it just feels different, right? It seems more elegant, more solid. Trust me, you're not alone. That's the intermediate wall. And today, we're going to give you the tools to smash right through it. So the first step on this journey isn't about learning some obscure library or a clever one-liner trick. Nope, it's about mastering the craft itself. We're going to focus on how to write code that's cleaner, way more expressive, and just fundamentally easier for you and your team to maintain. This is the bedrock that all great software is built on. Okay, let's make this super concrete. On the left, you see the classic way of writing a simple class just to hold some data. It works, sure, but look at all that extra code you have to write. All that boilerplate for just basic stuff like printing the object out or checking if two users are the same. Now, look at the right. This is the modern way, using data classes. With that one little decorator, @DataClass, Python writes all that boilerplate for you. And this isn't just about typing less. It means your code is way clearer about what it's trying to do, and it's so much easier to maintain. You need to add an email field, you just add it in one place, not three. It's a game changer. And speaking of decorators, what even are they, right? Well, think of a decorator like a little backpack you can strap onto any function. The function itself doesn't have to change at all, but now, suddenly, it has new powers. Maybe that backpack adds logging, so every time the function is called, it prints a message. Or maybe it times how long the function takes to run. It's an incredibly powerful way to add extra functionality to your code without making a mess. And this brings us to another absolutely crucial tool for pros, context managers. You see, anytime your code opens a file, or connects to a database, or grabs a lock, you have to make sure you release it when you're done, even if something goes wrong and your code crashes. If you forget, you get resource leaks, and that can bring your whole application down. Context managers, which you can easily create with the @context manager decorator, handle all that setup and cleanup for you, automatically. Using them is a sure sign of robust, production-ready code. Okay, so your code's foundation is solid. It's clean, it's modern, it's maintainable. Awesome. But now you're facing the next big challenge, making it perform. As your app gets more popular and handles more users, you're going to hit performance bottlenecks. So the big question is, how do you make your code fast and efficient when it needs to scale? So, your app is slow. Your first instinct might be to just start changing code randomly. Don't do that. Before you do anything, you have to answer one critical question. Is your code slow because it's just sitting around waiting for something, like a response from an API or reading a big file from a disk? That's called I/O bound. Or is it slow because it's doing really intense math or data processing? That's CPU bound. Your answer to this one question changes everything. And here's why. Python gives us three main tools to handle doing multiple things at once, and they are definitely not interchangeable. If your problem is I/O bound, like making 100 different web requests, threading is a great choice. But if you're doing heavy-duty, number-crunching work, threading won't help you because of something called the global interpreter lock, or the GIL. For that, you need multiprocessing, which sidesteps the GIL by running code in totally separate processes. And finally, if you need to handle a massive number of network connections at the same time, like in a chat server, asyncio is the undisputed king. The key takeaway is simple. You have to pick the right tool for the job. And just to really hammer home how powerful asyncio is, look at this number. Trying to handle 10,000 simultaneous connections with a traditional threaded approach would be an absolute nightmare. It would just fall over. But with asyncio and its event loop, that's not just possible, it's literally what it was designed for. This is the magic that powers a lot of modern, super-fast web frameworks. But here's the golden rule, and please never forget this. Never optimize based on a hunch. Before you go rewriting anything for performance, you have to measure and find the real bottleneck. Python has a built-in tool called cProfile that's like an X-ray for your program. It will tell you exactly which functions are eating up all the time. Profile first, then optimize. Always. All right, for our final section, we're going to zoom out. We're moving beyond just the code itself. Writing a clever script is one thing, but building, deploying, and maintaining a truly reliable system, that's the final leap to becoming a pro. This is all about how to ship software like a professional team does. Now, this might look a little intimidating, but the idea is actually really simple. A CI/CD pipeline just automates all the boring, repetitive stuff that happens after you finish writing your code. So imagine this, you push your new code. Instantly, a machine kicks in, runs all your tests to make sure you didn't break anything, packages your code up into something like a Docker image, and then automatically deploys it. You don't have to lift another finger. This makes your releases fast, safe, and repeatable, so you can focus on what's next. Think of this slide as your professional developer checklist. Seriously, ask yourself, are you using virtual environments like VNV to keep your projects from interfering with each other? Do you have a pyproject.toml file that clearly defines what your project is and what it needs? Are you using Docker, so your code runs the exact same way on your laptop as it does in production? Are you writing automated tests with something like PyTest to prove your code actually works? And, this one's huge, are you keeping secrets like API keys and passwords out of your code? Mastering these things is what truly separates hobby projects from professional-grade software. So let's just take a step back and look at the whole path we've just laid out. It's a journey for sure, not a destination. But the good news is, now you have a map. We've really covered 3 big stages here. First, forging that solid foundation by writing modern, maintainable code. Second, taming complexity and scale by picking the right concurrency tools and actually measuring your performance. And finally, shipping like a pro by mastering testing, packaging, and automated deployment. So that's the roadmap. It's clear, it's actionable, and look, you don't have to learn everything all at once. The most important thing is just to start. Pick one thing from this map that got you excited. Maybe it's cleaning up your classes with data classes, maybe it's writing your very first test with PyTest, or maybe you want to dive into asyncio. Just pick one and go for it. The only question left is, where will your journey begin?